Welcome back everyone to Learning by Teaching. Today we're in statics and we're going to do this problem 743, okay? It says determine the x, y, z components of the internal loading at a section passing through point B in the pipe assembly. Neglect the weight of the pipe and we're going to take F1 and F2 to be these values, okay? So what the question is basically asking us is to find the internal forces and moments about this point B, okay? So what we're going to do is that first we're going to cut our beam at my point B, and then we're going to replace this side of the beam with internal forces. So in order to do that, we're going to draw a free body diagram. So we're going to do free body diagram as always. So we're going to draw from my point B to my point where F2 is, and then I'm going to have this side of the beam where from F2 to F1, okay? So over here, as I said, this is my point B. And what are the internal forces that I will have? Well, for this problem, I would like to draw the coordinate system. So this is my Z direction. Then like this is my y direction, and then like this is my x direction. Okay, let's redraw this side of the beam like this. Okay, good. Now we'll have a normal force, internal normal force, that we're going to call it NBX. I'm calling it B because it's at my point B, and X because it's in the X direction. Then I will also have a force in the Z direction, but this force is a shear force. So we'll have a shear force at point B in the Z direction. We'll also have a force in the Y direction that we're going to call it shear force B in the Y direction. Now, why are these two guys shear and this other one normal? This is normal because when we cut over here, in my main figure, the area that is left is normal to this force. Well, from these other ones, it's not normal, therefore they're just the simple shear. We will also have some moments around my axis, so I'll have a moment around my x-axis, so I'm going to call it moment Bx. I'm going to have a moment that I'm going to call By around my y-axis, and then a moment around my z-axis that I'm going to call Mvz. Okay, so these are my internal forces and my internal moments around about my point B. Now what I have left is that I have F2. So F2 has 300 in the x direction, so I'm gonna put 300 newtons. So this is a 3, so 300 newtons. Then I have negative 500 newtons in the z direction, so 500 newtons going down. And then on my F1, I have 200 in the x direction, so like this. And then I'm gonna put 200, let's put it here. Then I will have in the j direction, I'll have negative, therefore it will be going in this direction, which is 100 newtons. And then in the z direction, I have negative 400. So I'm going to have it like this, negative 400. Okay? So this is the overall free body diagram. And for me, this is the key part of this problem. So if you guys make this free body diagram as neat and as better as you guys can, that's the key in order to solve these problems. Okay? So after we do our free body diagram, guess what? What are we gonna do? Well, of course, we're going to do some material forces. So there is nothing in the static if we're not going to do some material forces. So we are going to do the some material forces in the x direction. And what do we have? Well, first, I like to start with my unknown, the one that I want to find. So NBX. So we got NBX. Then in the x direction, I got 300 newtons and 200 newtons. All going positive, so I'm gonna have plus 300 plus 200 newtons. and this should be equal to 0. So in here we can solve for n bx, and we will find out that this is equal to negative 500 newtons when we solve for it, okay? Next, we can do the summatory of forces in the y direction, and what do I have? Again, we do have n, we don't have n, I'm sorry, we have the shear at point B in the y direction, so this guy over here. What else is in my y direction? Well, I have 100 newtons in my y direction, and that's all. And this 100 newtons is negative, so a negative 100 and should be equal to 0. If we solve for my shear By, will be equal to 100 newtons, okay? Next thing I can do is summatory of forces in the z direction. And what do I have in the z direction? I have my unknown, which is shear Bz. Then I have negative 500 newtons and negative 400 newtons. And all this should be equal to 0. Just in case you don't know which ones they are, is this 500 newtons and this 400 newtons, okay? If we solve for my unknown, my shear in the z direction, we will end up that is equal to 900 newtons. The only unknowns that we have right now are moments. So are my moments in the y, x, and z directions. So therefore, we're going to start applying summatory of moments around my axis. Okay? So let's start with the summatory of moments around my x direction. So in order to know about the moments, which ones are positive and negative, I use the right thumb rule. So in this case, if my axis is in this direction, I place my right hand on, and then I use my thumb, and then I place it like the axis, same direction as my axis. And then these fingers will tell me in which directions it's supposed to be rotating in order to get a positive, okay? So let's start with this. We will have an unknown, that is the moment around the x direction of my point B. So this guy over here, this one over here. And as you can see, if I were to place the thumb in this direction, then my fingers will tell me that the rotation has to be this way in order for it to be positive. Okay, knowing that, we can start applying our summatory of forces. And what do I have? Well, I don't care about this guy, neither this guy, and neither this guy on all my moments, because all of them are passing through the exact origin of the 3 axes. So I don't care about them in any summatory of moments. Okay, so we can forget about those. Okay, then I have 300 newtons, but these 300 newtons are in the x direction, so I don't care about this. Then I have this 500 newtons, but this 500 newtons doesn't have a distance with respect to my x-axis. Then I have 200 newtons, but it's in the direction of my axis, in the same direction, so x-axis. So I don't care about it. And then these 100 newtons, if we were to keep following the direction of this force, it will touch my x-axis, meaning that there is no distance. Therefore, the only thing I have is this 400 newtons with this amount of distance. Okay, so now, is this negative or a positive? So we apply the right hand rule. So if I place my thumb like this, we will want to rotate like this for a positive. This force, this 400, if I'm holding like this in here in this axis, will want to rotate me like that. Therefore, it's negative. So we got negative 400 multiplied by the distance. The distance is given in the main figure, 1.5. And this should be equal to 0. If we solve for mbx, this should be equal to 600 newtons times meter. Okay? So we're going to go and do a summatory of moments in the y direction, in the y-axis, above my y-axis. Then I have my unknown moment by. Then let's see what's next. This 300 newtons passes through my point, through my origin. I don't care about it. This 500 newtons, let's see. So we will have my y-axis like this. Therefore, the rotation I want will be in this direction. this 500 newtons will want to rotate me in that direction, so I'm going to have positive 500 multiplied by the distance. Well, the distance is from point B to my point where F2 is being applied, so it's 1 meter, so multiply by 1 meter. Okay, next force is this 200. I don't care about it. Why? Because this also doesn't have a distance with respect to my y-axis. Then I have these 100 newtons. I don't care because they are in the y-axis, the same direction. So the remaining that I have is this 400 newtons, and it's in the same direction. It's going down as that 500 newtons. Therefore, they're positive 400 multiplied by the distance. Well, the distance is the same. It's this length over here, which is equal to 1 meter. Okay, so multiplied by 1 should be equal to 0. If we were to solve for my unknown, my moment at point B in the y-axis, this should be equal to negative 900 newtons times meter. Okay, last thing I need to solve for is applying the summatory of moments around my z-axis, and the unknown is my moment at point B in the z direction. Okay, so what do we have? We don't care about this 300 because it's passing also through my z direction. I don't care about this 500, and I don't care about this 400 because they are in the z direction. Then the rest that I have is this 200 and this 100. Okay, so let's start. This 200, the distance with respect to my z-axis from here to here is this side, which we know is 1 meter. And this 100, the distance, so I apologize, the distance from here to here is this 200, from this 200 from here to here is this side, which is 1.5, and the distance for this 100 is this side, which is 1. So what we will have? Well, we will have, if we place our right thumb going up like this, so like this, and we make like following our fingers, we will realize that we want to rotate like this for a positive. This 200 is going to rotate me like that, therefore it's going to be negative. And then this 100 will also try to rotate me like this direction, so it's also negative. So both of them are negative, so I'm gonna have negative 200 multiplied by 1.5 and negative 100 multiplied by 1. All this should be equal to 0. And if we solve for my unknown, we will figure out that this will be equal to, well, this will be negative 100, and then this will be negative 300. Therefore, a total of positive, when they go to the other side, of 400 newtons per meter. Okay? So we found our normal, we found our 2 shears, and we found our 3 moments. Just to state, these negative values means that when I drew this free body diagram, I assumed the direction of this guy, of all these 6 guys. And when I drew this normal force in that direction, it's just telling me that it's going to the opposite side. So in reality, it should be going like that. That's all it means for this negative and for that negative. Thank you guys for watching. If you guys like the video, please push the like button, subscribe, and comment anything that you have a question down below, and I'll see you guys in the next one.